In this video, we will find the solutions to the questions in exercise 3.4. This exercise is related to finding solutions of trigonometric equations. In the previous video, we have derived three formulas. That means we have proved three theorems by which we can find solutions to trigonometric equations in particular format. Means sin x is sin y, cos x is cos y, tan x is tan y. So those three are enough to find solutions to any trigonometric equation. So here the question is, find the principal and general solution of the following equations. What is the meaning of principal solution? Principal solution means that value of the variable in the trigonometric equation, means that angle which lies between 0 to 2 pi, means 0 included, 2 pi not included. So whenever the angle which is the solution of the trigonometric equation lies from 0 up to 2 pi, such a value or such a solution is called principal solution. But the integral multiple of that value which is called solution, that is called general solution. So to understand this better, we will let us answer these questions. The first bit is that tan x is root 3. Before answering this is related to which theorem? This is related to tan x is equal to tan y. Solution to this trigonometric equation is the value of x in terms of y, and we have derived that formula by which we can find solution to this equation. Solution is x is equal to n pi plus y. That means if we can find this y, we can substitute here and we will get the general solution. Why this equation will be called as general solution? Why? Because it has got the integer n. N belongs to the set of integers. In place of n, when we put 1, 2, 3, 4, etc., then we will get good number of solutions. Out of those solutions which are less than 2 pi, they will be called as the principal solution. First, let us find the general solution and then we will find the principal solution. So, tan x is root 3. Now find out root 3 is for which value of tan we get root 3. Tan of 60. So tan of, we will not write 60. Why? Because these angles are in terms of radians. So tan of pi by 3, 180 by 3 is a 60. So here tan x is equal to root 3, which is equal to tan pi by 3. Now just observe these two. Tan x is a tan pi by 3, something of the form tan x is equal to tan y. So this happens to be the y. So what is the general solution of this trigonometric equation? This is called trigonometric equation. Why? Because equation is equal to is involved and the trigonometric ratios are involved. So what is the general solution? Which is n pi plus y, and y happens to be pi by 3. So x is equal to n pi plus pi by 3 is the general solution. So x is equal to n pi plus pi by 3 is the general solution, and the principal solution is pi by 3 and 4 pi by 3, as these two angles lie between 0 and 2 pi. Exercise 3.4, second question. We have to find the general solution and principal solution of this trigonometric equation. How to do this? We don't have any theorem related to sec, but we have a theorem related to cos. So we can write this as 1 by cos x. In that case, on exchange of these terms, we will get cos x is equal to 1 by 2. Since we know that when cos x is equal to cos y, then solution to this trigonometric equation is a value of x in terms of y, and x is equal to 2n pi plus or minus y. That means we have to write this in form of cos x is equal to cos y. Right now we have cos x. So 1 by 2 is cos of which angle? 1 by 2 is cos 60. means cos pi by 3. So this one is cos pi by 3. Now we have cos x is equal to cos y. So this part is y. So general solution of given equation is x, which is 2n pi plus or minus pi by 3. How to find the principal solution? One of the principal solution is pi by 3 itself. So the principal solutions are x is equal to, in place of n, when we put 1, we will get 2 pi plus pi by 3. This angle is a 2 pi plus something, means it is greater than 2 pi. So this value is 6 pi plus 1, 7 pi by 3 is not the principal solution. So what are the principal solution? One, directly we will take, the principal solution is pi by 3. Another, we will take it as 5 pi by 3. Use a minus, negative. Then this is 1. So in place of n, when we put 1, we get 2 pi. Plus will not work out, that will cross the principal solution value. So minus of pi by 3. So this turns out to be 6 pi minus pi by 3 means 5 pi by 3. So these are the only two angles which lie from 0 up to 2 pi. So these two, since they lie between 0 and 2 pi, these two are called the principal solutions of sec x is equal to 2. Exercise 3.4, third question is cot x is a negative root 3, and we are supposed to find its general solution as well as principal solution. Since we don't know any theorem related to cot, we have to convert this to tan. Cot is 1 by tan x. On reciprocating, we will get tan x is negative of 1 by root 3. Now tan of an angle is a negative of the number. Tan is negative in which quadrants? Tan is positive in only third quadrant. It is negative in second quadrant and in fourth quadrant. If this angle x lies in second quadrant, it will be in form of pi minus theta. And if the angle lies here, the angle appears in form of 3 pi by 2 plus theta. Since this is odd multiple of pi by 2, 3 is odd. So odd multiple of pi by 2, tan will get converted to cot. So we will consider that this angle lies in second quadrant. So tan of which angle is negative 1 by root 3? Tan of pi minus theta is in second quadrant, due to which it became minus 1 by root 3. We only have to find what is a theta. Theta, how to find? For theta, we should understand that tan of which angle is 1 by root 3. In terms of radians, it is pi by 6. So we will rewrite this equation as tan x is a negative of 1 by root 3, and which is tan of pi minus pi by 6. So tan x is equal to tan y. Now recall that if tan x is equal to tan y, then x is called a solution of this equation, which will be given in terms of y. So here this is x, this is a y. So x is equal to n pi plus y. So solution to this equation, which is actually solution to this equation, which is actually solution to this equation, is first I am writing the general solution. So x is equal to n pi plus y. Y is this, and what is this? 6 pi minus pi, which is 5 pi by 6. So this happens to be the general solution. When we want to find the principal solution, in place of n in the general solution, we have to place different integer values and find for which integer value on solving x comes to be an angle that lies from 0 up to 2 pi. Okay, so first n as 0. If n is 0, the first principal solution is 5 pi by 6. That means this angle itself is one of the principal solution. Next one is 11 pi by 6. Now you don't think anything, because in place of n, if you put any negative values or more than 1, then we are going to get an overall angle, this on simplification, greater than 2 pi, which cannot be the principal solution. So general solution is x is equal to n pi plus 5 pi by 6. Principal solutions are 5 pi by 6 and 11 pi by 6. The fourth question is, we have to find general solution and principal solution of cosec x is a negative 2. Since we know that cosec is 1 by sine, we can write this as a sine x is negative 1 by 2. So sine of an angle is a negative. Sine is negative in which quadrant? Sine is positive in the in the second quadrant, and it is negative in third quadrant and in fourth quadrant. So this sine of this angle must be in third quadrant. Why? Because with respect to x-axis, sine remains a sine. But if with respect to y-axis, sine gets converted to cos. So it should be in the third quadrant where sine of the angle is a negative. So this zone, every angle is in form of a pi plus theta. In this zone, it is a pi minus theta. So sine of which angle is 1 by 2? Sine 30. Sine 30 means what? Sine of a pi by 6. But how to write this angle? This angle should be written in this form. This one is that pi by 6. So sine of a pi plus pi by 6. So we get this equation in form of sine x is sine of pi plus pi by 6. This is in the form of sine x is equal to sine y, and if sine x is sine y, then x is called solution to this trigonometric equation, which is x is n pi plus minus 1 to the power n y, and y is this angle. This is sine x is equal to sine y. This angle is this. So what is the general solution? N pi plus minus 1 to the power n y. And what is this angle? 6 pi plus pi, that is 7 pi by 6. So this is the general solution. Then what is the principal solution? Principal solution is this angle itself. Principal solution is x is equal to 7 pi by 6, since this angle lies between 0 up to 2 pi. Now the next set of questions. Find a general solution for each of the following situations. The first situation is fifth question, which is given as cos 4x is equal to cos 2x, and we have to find solution. Solution to this equation is finding the value of this variable. Variable is x. So this has to be written in form of a cos x is equal to cos y, so that we can write x as 2n pi plus or minus y. So first we will rewrite this in proper format, which is cos 4x minus cos 2x is 0. Now this is brought in form of a cos c minus cos d. Cos c minus cos d is a negative 2 sine c plus a d by 2 means a 6x by 2, that is a 3x, times a sine c minus d by 2 means 4x minus 2x, that is 2x by 2, which is x is 0. Negative 2 can't be 0, so this is 0 or this is 0. When sine 3x is 0, we have to think that sine of which angle or which angles are 0. So we know that sine is 0 for multiples of a pi along x-axis. Positive x-axis, that's 0, negative x-axis 0, like 0, pi, 2 pi, like that. So sine 3x is 0, sine of multiples, integral multiples of pi is also 0. So here in a very simple way we can write, by comparing both sides, 3x is n pi, x is n pi by 3. So this is the general solution of this equation, but this is one of them. We'll find the other one when sin x is 0. If sine x is 0, sine is again sine of which angles are 0? Sine of multiples of pi is 0. Now we compare these two and we will get x is equal to n pi, and this is the next solution. So what are the general solutions of cos 4x is equal to cos 2x? There are two of them, n pi by 3 and n pi. The fifth question is cos 3x plus cos x minus cos 2x is 0. We are supposed to find its general solution. So sixth question. To find the solution to this, first we have to condense this in form of cos x is equal to cos y, so that we can write x is equal to 2n pi plus or minus y. For condensing, we will consider these two terms first. It is in form of cos c plus cos d. So cos c plus cos d is, using the identity, 2 cos c plus d by 2, which is 4x by 2, so 2x, times cos c minus d by 2, which is 3x minus x, means 2x by 2, so x. And then the third term is cos 2x is 0. We see there is a highest common factor cos x throughout. So we will take cos 2x as highest common factor. What goes in the bracket is a 2 cos x minus, this is already out, so 1 is a 0. Now either this factor is equal to 0 or this factor is equal to 0. When cos 2x is equal to 0, we have to think cos of which angle is 0. Cos pi by 2 is 0, cos 90 is 0. In that case, cos of odd multiples of pi by 2 is also 0. So we will write this as cos of odd multiples of pi by 2, means 2n plus 1. This number is called odd number. 2n is even, 2n plus 1 is called odd. So this one, pi by 2. Odd multiples of pi by 2 is 0. Pi is 180, 180 by 2 is 90. So 90, odd multiples of 90 is 0. Now we will compare these two and we will get 2x is equal to 2n plus 1 pi by 2. Since we have to solve this equation, solution to this equation is a value of the variable that we see. Variable is x. So we want the value of x. So dividing throughout by 2, we will get x is equal to 2n plus 1 pi by 2, and this 2 makes it 4. So this is one of the solution to this equation. Can we have another equation? Can we have another solution? There can be another solution, because when this was equal to 0, this was a solution. What about when this is equal to 0? When 2 cos x minus 1 is 0, we will get cos x is equal to 1 by 2. Now we have to think about cos of which angle is 1 by 2. Cos 30 degrees is 1 by 2. So cos of pi by 6 is 1 by 2. So cos 60 is 1 by 2. Cos 60 is 1 by 2 means pi by 3 is 1 by 2. Now comparing this, we will get x is equal to pi by 3. Or we can write this as, this is a principal solution. We can write the general solution as cos x is equal to cos of y. So general solution is x is equal to 2n pi plus or minus pi by 3. So solutions to the given equation is this as well as this. Now seventh question is sin 2x plus cos x equal to 0, and we have to find general solution of this equation. Solution to this equation means a value of that variable here x, which is expressed as integral multiple of pi. Before solving this, we have to write this in form of sin x is equal to sin y, or cos x is equal to cos y, or tan x is equal to tan y to get that general solution. So first we have to simplify. We know that sin 2 theta is a 2 sin theta into cos theta. So we can write this as a 2 sin theta into cos theta this one cos x as it is. We have a highest common factor. Highest common factor is cos x. What goes into the bracket is 2 sin x plus 1 is 0. Now either this is 0 or this is 0. When cos x is 0, we will have one of the solution. So first we have to think about cos of which angle is 0. Cos of pi by 2. Cos 90 is 0. Cos 0 is 1. So cos 90 is 0. Cos 90 is 0 means cos of odd multiples of 90 will also be 0. So here cos of 2n plus 1. 2n is even, 2n plus 1 is odd, pi by 2. So cos of odd multiples of pi by 2 is 0. Now when we compare this, we will get x is equal to 2n plus 1 pi by 2. So this is one of the solution of the given equation. Then we have one more factor which turns 0, that is 2 sin x plus 1 is 0. That implies sin x is negative 1 by 2. We have to think about sine of which angle is a negative number. Sine is negative in third quadrant and in fourth quadrant. Sine is positive in the second quadrant. Since sine of this angle is negative, that means this angle x can lie in the third quadrant. Every angle in third quadrant is in form of pi plus theta. We only have to find theta. How to find theta? We have to think about sine of which angle is 1 by 2. That angle is theta. Sine 30 degrees is 1 by 2. So pi theta is 30. 30 means what? Pi by 6. So sine of the angle is negative 1 by 2. Negative 1 by 2 is the value of sine pi plus pi by 6. So ultimately we are getting sine x is equal to sine of 7 pi by 6. 6 into pi, 6 pi plus 1, 7 pi. 7 pi by this. Now this is in that general form where we can find the solution. If sine x is equal to sine y, then x is equal to n pi plus minus 1 to the power n y. And here y is 7 pi by 6. So the solution to the given equation is either 2n plus 1 pi by 2 or n pi plus minus 1 to the power n 7 pi by 6. Question number 8. We are supposed to find the general solution of a sec square 2x is equal to 1 minus tan 2x. We will write sec square theta as 1 plus tan square theta. Right side as it is 1 minus tan 2x. We can cancel the like terms and we can transpose this to the other side to get a standard form of the equation. So tan square 2x plus tan 2x is 0. Take highest common factor. Highest common factor is tan 2x. What goes in the bracket is another tan 2x plus this is already out. So 1 is a 0. Now either this is 0 or this is 0. To find solution, we have to equate each factor to 0. So when tan 2x is 0, we have to think about tan of which angle is 0. Tan of multiples of a pi is 0. How? Tan is actually, tan theta is a sine theta by cos theta. We know that say theta is 0 times a pi. 0 times a pi. So it is a multiple of pi. So sine 0 times pi means a 0. Sine 0 is a 0. Cos 0 is a 1. So 0 by 1 is a 0. So tan of an angle is 0 for a multiple of pi. So tan 2x is 0. Its meaning is a tan of n pi. Multiples of pi is 0. So we can compare this and we will get 2x is equal to n pi and x is equal to n pi by 2. This is one of the solution. Other solution we will figure out from here. So tan 2x plus 1 is 0. So this is tan 2x is a 1. Tan of which angle is 1? Tan of 45 degrees. means a pi by 4. We have to write answer in terms of radians, angles in terms of radians. So tan 45 is 1. So tan pi by 4 is 1. So we got in this format, which we will write it as the standard form. Tan x is equal to tan y. So x is equal to n pi plus y. So here we are writing x, means here it is 2x is equal to n pi plus y. Y is pi by 4. Divide throughout by 2 or this 2 transpose. So we get x is equal to n pi by 2 plus pi by 8. Okay, tan 2x plus 1 is 0. So then tan 2x is a negative 1. Okay, fine. So tan of an angle is negative. Tan of an angle is negative in which quadrant? Tan and cot are positive in the third quadrant. So tan is negative in which quadrant? It is negative in second quadrant as well as fourth quadrant. If it is in second quadrant, the angle is in form of pi minus theta. So here tan of which angle is 1? Pi by 4. But where is this angle? This angle is in second quadrant. So here theta can be taken as pi by 4. Then tan of pi minus pi by 4. Pi minus pi by 4. Pi minus pi by 4 is a negative 1. So pi minus pi by 4 is 3 pi by 4 done. So this angle is 3 pi by 4. 3 pi by 4. So one of the solution to this equation is x is equal to n pi by 2. Another solution is x is equal to n pi by 2 plus 3 pi by 8. Why? Because 2 is transposed. So this was negative. As a result, it cannot be just a tan pi by 4. Tan 45 is plus 1, not minus 1. And if it is minus 1, the angle is in second quadrant. In second quadrant, every angle is in form of pi minus theta or pi by 2 plus theta, but with respect to this, tan will not remain tan, it will become cot. So this is a solution, this is a solution. The ninth question of exercise 3.4, the last question, we have to find the general solution of this trigonometric equation, means finding the value of x. So we cannot find direct solution. So we have to first simplify this. For simplifying, we have to take two terms like these two in form of sin c plus sin d and apply sin c plus d formula and further reduce it and get the solution. So when we take these two, we will get sin c plus d by 2 some 2x, c minus d by 2 some x, and then we cannot simplify further because 5x is a bigger one. So we can take either these two. When we take these two, we will get sin c plus sin d. So 8 by 2 4x and 2x by 2. Okay, fine. We can take these two as a set, or we can take these two as one set. Then also sin 3x will be the extra term which will serve as highest common factor. But however, I am taking these two as one set. This appears to be sin x plus sin c plus sin d. Sin c plus sin d is a 2, sin c plus d by 2. So 8x by 2 is 4x times cos c minus d by 2 means 3x minus 5x means minus 2x by 2 means a negative x. So you can see and understand that when we take these two combination, we are not getting any highest common factor. So we can drop this combination. Even this combination won't work. So we will take this combination. So this choice not taken. So I'm putting these two, the first and last, as one entity and 3x other way. So I'm just taking the other option. So we will take sin x plus sin 5x plus sin 3x is equal to 0, and this one is sin c plus sin d. which turns out to be twice sine of c plus d by 2. 6x by 2 is a 3x. See, we have one more 3x. So this is the correct combination, times cos of c minus d by 2 means x minus 5x is negative 4x by 2. So negative 2x plus the extra term sine 3x is 0. What is the highest common factor? Sine 3x. This is the highest common factor. So I'm taking sine 3x out. What goes in the bracket is a 2. Here cos of negative, cos is even function. So cos minus theta is cos theta, means plus cos theta. So this turns out to be cos 2x plus sine 3x is already taken as highest common factor. This is 1 is a 0. Now either this is 0 or this factor is a 0. So when sine 3x is a 0, we have to think about sine of which angles are 0. By this time we understood that sine of multiples of pi is a 0. So we have sine 3x is equal to sine n pi. Now we can find the value of x on comparing these two. 3x is n pi. Divide throughout by 3, we will get the value of x, which is our requirement, which is n pi by 3. This is one of the solution. The other solution we will get from the second bracket, which is 2 cos 2x plus 1 is a 0. Writing this properly, we will get cos 2x is negative 1 by 2. Now cos of an angle is negative. Cos of an angle is negative in which quadrant? Cos and sec are positive in fourth quadrant, negative in second quadrant and in third quadrant. Get x, which is n pi plus or minus pi by 3. This angle belongs to the second quadrant where cos of the angle is negative. So this is a solution to question number 9.